Everyone, welcome back to another video from the series, and today I decided to solve 2018 AMC 12B problem 17, and I actually uploaded a new solution for this problem, so I think it's like solution 5. It will say like something, it will be represented as Mephicon because that's the ID that I use for AOPS. So yes, so this is actually going to be the new solution, so I hope you enjoy it. And yeah, so let's start. So what I first did from here is that I realized that P and Q are positive integers, so I decided to use this property. So we know that if this is less than 1, then this thing is less than. We can use this property right here. I'll say n because we don't know, but it continues indefinitely, so I think I don't have to write that. So I was like, wait, maybe we can use this, like somehow use it. And also the main reason why I did that is because I think I can find the range for P over Q. That's why, like a smaller range, so that's why I did that. And maybe if I make the common denominator, I will find something. So I also did that one too. So we have this is less than this. So it's actually, oh, oops, my bad. So it's actually really interesting to see that we have one difference in the numerator when we make the common denominator. So maybe, just maybe, we can do the same thing. And because this fraction increases, like it increases a lot until like I think 1. And the reason why I say 1 is because when we find the limit of when n approaches infinity of a plus n over b plus n, then it is simply 1. Therefore, there will be a time when this thing, like, it should be something less than 36 over 63, because ultimately it will be like something less than 1. So that's why P over Q should be in here somewhere. Now, an interesting thing that we can do is we can find a smaller range for P and Q by saying, like, by finding the range for n here. So let's say that this is equal to each other. So like at some point they might be equal to each other, so they might not be. So depending on that, we can also compute P over Q. That's why I decided to do this. Now, oh wait, not P over Q, sorry, because if you do P over Q, then we cannot like do anything. So when this is equal to 36 over 63, we might be able to do something. So it's 63 times 35 plus 63, n is equal to 36 times 63 plus 36n. This should be 63, I think, and when we subtract this, it's 27n. Yeah, so actually in this case, n is equal to 7 over 3. Wait, is it right? I think so, yes. It's 7 over 3. That means 35 plus 7 over 3 is equal to 36 over 63. However, this thing, it is less than 35 plus 1, 2 over 63 plus 2. And this thing is less than 35 plus 1 over 63 plus 1. And this is clearly, this thing is clearly greater than, sorry, I was saying it wrong, 35 over 63. So therefore, we can conclude that P over Q should be one of these two values, like 37 over 65 and 36 over 64. These are the only choices. Or else it will not make sense. Our inequality will not make sense. Now we need to find q minus p, and q is smallest as small as possible. Then we need to simplify them. So q, so our denominator is clearly not this one. So therefore, this thing is equal to 4 times 9, so 9 over 16. So therefore, our answer should be 16 minus 9 equals 7. And I think this is correct answer. So this is the solution that I recently came up with. So if you like the solution, please comment anything below. If you think there is something wrong with the solution, or if you have better solution, please also write that. And for this problem, I think the key point or the kick is noticing this one, and noticing the fact that the limit of this expression as n approaches infinity is equal to 1, and therefore we can use this one right here. And to find the limit, what am I saying? To find the range of p over q, we can let this one, and then ultimately find our value. So I think this was relatively easier compared to the other problems. And like I mentioned yesterday, I was actually trying to do IMO problem, but to be honest, I was quite lazy. I was not able to study like thoroughly today. Like, yes, I had other like church schedules after the retreat, so that's why I'm planning to make the video tomorrow. So I hope to see you tomorrow, and thank you, and see you tomorrow. Bye.